welcome back to my Amateur Radio General License course. I find it interesting that some people who might otherwise enjoy amateur radio avoid it because they don't think they're capable of learning it. And the same thing may be true of some technician class license holders who are asked why he or she doesn't go for a general, and maybe some general license holders that don't go for their extra. The key word here is think. In Chris Voss's master class on the art of negotiation, he asserts that it isn't what we know, it's what we think. And it's really true, I believe. In other words, if you think you can pass a general exam, you will. But if you think you can't pass it, you most likely won't. When we think we can do something, we simply just need to learn how. My hope is that you believe you can pass the general license exam, and that my course will provide you the knowledge and the understanding to facilitate your goal. Are you ready to learn about amateur radio? Well, let's get started. This is the Amateur Radio General License course, Lesson 4, Part 1. I'm your instructor, Gary Stevens, Kilo Echo 2 Golf Sierra. That's KE2GS. This is SUBELEMENT G4, Amateur Radio Practices. There's 5 exam questions out of 5 groups of 67 questions total. This covers the 2019 to 2023 General Class FCC Element 3 question pool, which was effective July 1st, 2019. This lesson covers station operations and setup, test and monitoring equipment, such as the two-tone test, interference to consumer electronics, grounding and digital signal processing, speech processors, S-meters, sideband operation near the band edges, and HF mobile radio installations, alternate energy sources of operation. So let's dive right in with station operation and setup. So if you hold the belt up to the light and look through one of the notches, you notice that it only lets just a tiny little sliver of light through. Well, the same thing is true with a notch filter with the radio waves. For the purpose of the exam, you need to know that the purpose of a notch filter found in many HF transceivers is to reduce interference from carriers in the receiver passband. When using CW, sometimes you can reverse or use the opposite sideband. For the exam, you need to know that one advantage of selecting the opposite or reverse sideband when receiving CW signals on an HF transceiver is it may be possible to reduce or eliminate interference from other signals. Yes, some people like to operate in a split mode. And what does this mean? It means that you're talking on one frequency and listening on another. So for the exam, you need to know what is normally meant by operating a transceiver in a split mode is the transceiver is set to a different transmit and receive frequencies. This is a photograph of an antique plate current meter or grid dip meter. For the purpose of the exam, you need to know that the reading on a plate current meter of a vacuum tube RF power amplifier indicates a correct adjustment of the plate tuning control is a pronounced dip. And that's where they come up with the grid dip meter, because you get a dip. Because there's some drift in the power or fluctuations in the power in power amplifiers, particularly with tube type, they came up with automatic level controls to prevent distortion. For the exam, you need to know that the reason to use an automatic level controller, ALC, with an RF power amplifier is to reduce distortion due to excessive drive. In my mind, one of the greatest inventions ever conceived for amateur radio is the auto tuner. Um, for the exam, you need to know that an auto tuner or an antenna coupler is a type of device that is often used to match transmitter output impedance with the impedance not equal to 50 ohms. Here we have a photo of a burned up power amplifier. Um, Take a good look at that because you don't want that to happen. It's an expensive repair. For the exam, you need to know that excessive drive power is a condition that can lead to permanent damage to a solid state RF power amplifier. So don't turn it up all the way. Even today, some of the most powerful amplifiers for radio are still tube type amplifiers. For the exam, you need to know that the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier is maximum power output without exceeding maximum allowable plate current. Time delays are important. You may know that notice if you're talking in voice, somebody could walk on somebody by keying up too soon, and while other people are still talking, so that's messing up the receive and the send. It's more critical with data where the data can become corrupted if not there's not a delay. For the exam, you need to know that a time delay is sometimes included in the transmit keying circuit to allow time for the transmit-receive changeover operation to complete properly before RF output is allowed. Please excuse my awkward demonstration of an electronic keyer. I had my cell phone in one hand recording it and trying to hold the key in the other. Um, I hope you get the gist of an automatic keyer or electronic keyer. For the exam, you need to know that automatic generation of strings of dots and dashes for CW is the purpose of an electronic keyer. As shown in the magnifying ring of this photo is of a TS 440 is the IF shift control. You need to know for the exam that a use of the IF shift control on a receiver is to avoid interference from stations very close to the received frequency. Not all HF radios have dual VFOs, but some do. Like this TS50, you can see the A and the B. Each one is a VFO. For the exam, you need to know that a common use of a dual VFO feature of a transmitter is to prevent monitoring of two different frequencies. It also allows you to operate in a split mode. You need to know for the exam that one reason to use the attenuator function that is present on many HF transceivers like this TS590 is to reduce signal overload due to strong incoming signals. For the exam, we need to know that improper action of ALC distorts the signal and can cause spurious emissions. It's likely to happen if a transceiver's ALC system is not set properly, particularly when transmitting AFSK signals with a radio using single sideband mode. Now, RF gets into everything, particularly with audio cables. In the picture here, it has ferrite beads that get rid of a lot of RF. Before the exam, you need to know that a Vox circuit does not unkey the transmitter. The transmitter signal is distorted, or a frequency connection times out, are all symptoms of RF getting into your audio cables when you're using data modes like AFSK with your computer and your transceiver. A noise blanker does exactly what its name implies. It blanks out noise. And the way it works is by reducing the receiver gain during the noise impulse. And this is particularly useful if you have a car with a noisy ignition system. As you might guess, this photo is a distorted signal. For the exam, you need to know that as the noise reduction control level in a receiver is increased, the received signals may become distorted. Distortion is not always good. And this brings us to the next section, test and monitoring equipment and two-tone tests. Here we have a block diagram of an oscilloscope. You notice that there's a vertical and a horizontal amplifier, as well as a CRT or cathode ray tube. For the exam, you need to know that an oscilloscope is a piece of test equipment that contains a horizontal and vertical channel amplifiers. We also need to know that an oscilloscope versus a digital voltmeter, an advantage is that we can see complex waveforms. Here we see a square wave and a sawtooth wave. An oscilloscope is the best instrument to use when checking the key and waveform of a CW transmitter. And the reason is because you can tell if the sine wave or the audio generated is clean or if it's distorted. Attenuation is something that's just simply reducing it. So if you attenuate a signal, you're just reducing the strength of it. For the exam, you need to know that the attenuated RF output of a transmitter is connected to a vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal. And in the photo is an attenuator for an oscilloscope. Without a refresher in Ohm's law, just suffice it to say that, or take this for face value. For the exam, you need to know that a high impedance is desirable for a voltmeter because it decreases the loading on circuits being measured. To me, it's intuitive, but in case it's not for you, a digital voltmeter is a lot more accurate. You can be carried out to several decimal places. You can't get that kind of accuracy on a meter. For the exam, you need to know that the advantage of the digital voltmeter as compared to an analog voltmeter is that it has better precision for most uses. A two-tone test is just simply two non-harmonically related audio signals. A good example of that is the old touch-tone telephone. If you have ever seen one, you know what I'm talking about. For the exam, just know that two-tone non-harmonically related audio signals are used to conduct a two-tone test. A field strength meter is a useful device that's commonly found. You can buy them anywhere online. For the exam, you need to know that a field strength meter may be used to monitor relative RF output when making antenna and transmitter adjustments. They're also useful in doing your antenna analysis. In this photo, you can see a little vertical line in the middle if you squint real hard. And then you can see the circles which represent the radiation pattern of that antenna. For the exam, you need to know that the radiation pattern of an antenna can be determined with a field strength meter. Directional watt meters are kind of handy. For the exam, you need to know that the standing wave ratio can be determined using a directional watt meter. Antenna analyzer is one of my favorite pieces of equipment because you can test an antenna without even connecting it to a radio. For the exam, you need to know that the antenna and feed line must be connected to an antenna analyzer when it is being used for SWR measurements. This image shows a signal near the middle, and to the left of it a stronger signal. Sometimes when we're making adjustments, the stronger signal can override what we're trying to adjust. For the exam, you need to know that strong signals from nearby transmitters can affect the accuracy of measurements when making measurements on an antenna system with an antenna analyzer. Also for the exam, we need to know that an antenna analyzer, besides being used to measure the SWR of an antenna system, it can also be used to determine the impedance of the coax cable itself. It could stir up a debate between analog and digital devices, accuracy and whatever. But sometimes meters have an advantage over the digital meters. An analog meter, we can watch the movement. For the exam, you need to know that an instance in which the use of an instrument with an analog readout may be preferred over an instrument with a digital readout is when adjusting tuned circuits. And the last question in section G4B, they want us to know that a two-tone test analyzes the linearity of a transmitter performance. And this concludes Lesson 4, Part 1. I hope you've enjoyed today's lesson. Please hit the like button below and subscribe if you haven't done so. The subscription enables you to be notified when there are new videos or updates that are released. Until next time then, never stop learning.